We're starting 14.5, which is on surface area using double intervals. Hopefully you watched the videos. One of the equations for surface area is in blue on this screen. You can see the derivation in the videos. And we're going to work on our first problem, which is finding the surface area of the plane 2x plus 2y plus z equals 8 in the first octant. Octant, if you're unfamiliar with it, is the 3D version of quadrants. There are, since the X, Y, and Z axes break up real space into 8 different regions, they're called octants. The first one is where all X, Y, and Z are positive. I don't know how they number them after that. Like, it's easy. I know how they number them in 2 space. We go counterclockwise. How do they number the octants after the first octant? I don't know. That's kind of deep.
Eric just looked it up for us. Let's see. So they go positive y x z for 1, positive y negative x positive z for 2, negative. Oh, I see. So they go counterclockwise. They do the same for 2 space for the top,
and then they drop down to below the z-axis for the other half.
Yeah. So essentially,
Okay.
they just start over.
Okay, that makes sense.
Well, because the top is at the top. Yeah, you're just nothing. But it's the morning. This is the best time to do calculus. Calculus and coffee, the best way to do calculus.
Or you can actually be awake normally like a normal person.
Hey, if you really want to do that, figure be my guest. It's like calculus and coffee.
Calculus and cocaine. Get it right.
I don't.
I am joking. I am joking. That was a joke.
I too like Coca-Cola.
You shouldn't do calculus and cocaine. It's meth.
Yeah, he's recording.
Oh man. Don't put that in the video.
Somebody knows if he was actually good, if he would be actually broken if he wasn't recording.
I know you're drugs and cow.
What we're eating on integrals.
That sounds like, but
I'm not worried about
So how should we go about doing this? Has anyone started? Is there everyone just gossiping? Other than Eric, I see Eric working.
find the root.
What do I got to do to find the derivatives?
Make it into a function of
We're doing it implicitly. So
function of zxy.
I think making it a function of zxy is the easiest way to go. And how would we do that?
So partial zx equals to -5 next to 2.
Okay, so you said -2. What I'm thinking is what you did was this. Subtracted 2x and 2y over the other side. So now z is a function of y.
Right.
And x. So now we can find dz dx. And they happen to be the same here. They're both -2. Okay, so that'll get us our integral, right? We got at least, well, what's in the radical? We got -2 squared plus -2 squared plus 1. 4 plus 4 plus 1 is 9. Square root of 9 is 3. So we have our 3 is what's going inside the integral. What are my limits of integration? Well, if we resketch this region of the XY plane, we have a point at 0, 4 and a point at 4, 0. If you don't recognize that as the line negative y equals negative x plus 4, you can do a little bit of rise over run. M equals 4 minus 0 over 0 minus 4, and we get -1 for the slope. And then we've got y minus y1 equals m times x minus x1. Y minus 4 equals -1 times x minus 0, so -1x. And so y equals negative x plus 4. There's your algebra recap for those of you that don't remember finding lines. So we just got to decide which one we want to do first. If we go do dy first, we'll go from 0 to negative x plus 4. And then the outer integral will be x is 0 to 4. 3 dy dx. So we've got 0 to 4 on x. I've got 3y evaluated from 0 to negative x plus 4, or 4 minus x dx. This just looks like 12 minus 3x, right? And we finish this off. We've got 12x minus 3 halves x squared, evaluated from 0 to 4. 12 times 4 minus 3 halves times squared is 16. I've got 48 minus, reduce that, minus 24. Looks like 24 is the area.
The greatest eyelash.
Any questions?
Not really. Oh, we use the bungee slope. It's the.
I think we got a couple people still writing things down now.
Yeah, I see people still writing.
Trying to make sure to write down the slope thing. You need it, that's how you find the interval. That's good.
So the other form of this surface area, when we parameterize it, the surface, this is S, and then S is also the double integral of the magnitude of dr du cross dr dv du dv. Why are you writing stuff down? Oh, R is a vector. That's definitely a V there.
Yeah, it would have to be a vector if you wanted to cross them after all.
Right.
Yeah,
You guys ready for another one?
Let's,
normal vector for that plan or?
Let's do it. If you need that up longer, let me know. Otherwise, we're going on.
and that would give you a normal vector. It would give you surface. Should that make sense? No way.
So we want to find the surface area of z equals xy. We're going to bound it by y equals 1 over root 3x. X squared plus y squared equals 9. And we're going to have it in quadrant 1. And y greater than 0. So we're looking at this wedge right here. Pro tip, it looks like it's a polar type thing. Not only from the picture, but the equation. We should switch to polar. So I'll do a hard part. R goes from 0 to 3. What about theta? I can see the bottom line is 0. What's the upper line? You say pi over 4?
You'd have to let's see.
I have no idea.
Let's pull this equation, this y equals x over root 3. Or y equals 1 over root 3x. How do we find, what's our equation for polar?
Tangent theta y over x.
R goes.
Theta equals tangent inverse y over x. Or tangent theta equals y over x. Well, we can get that relatively quickly. Y over x is 1 over root 3, which is root 3 over 3. So that's got to be theta. Or tangent inverse of that. So theta equals tangent inverse of root 3 over 3. Where does that occur?
Pi over 6.
5 or 6.
You get y over x. Divided by x over.
So let's rewrite our equation. I've got z equals r cosine theta, r sine theta. So z equals r squared cosine theta, sine theta. And if we want to get it down to one trig function, we could take advantage of sine 2 theta is 2 sine theta cosine theta. So if we multiply by 1/2, we get 1/2 sine of 2 theta equals sine theta cosine theta. And I could make this z equals 1/2 r squared sine of 2 theta. We're getting there. We got our stuff in polar. Now we need to come up with the formula for the surface area. So dr du cross dr dv du dv, or d, I'm going to put dA because it depends on what we shift to. So here it looks like r and theta are natural things to go to. So r, any point on our vector r is x, y, z. So dr, the radius, maybe we should write out what this is before I do that in terms of polar. So dr, I'll move that a little lower so we can do the cross product right away. And r of theta bring the 2 down, we got r squared cosine 2 theta. I do everything right there. We're good? So if we do the cross product, Jesus, this is ugly as hell, isn't it? The I component is r squared sine of theta cosine of 2 theta. The j component is we got negative r squared cosine theta cosine 2 theta minus, which is a plus, r squared sine of theta sine of 2 theta.
Mr. Jones, I don't know if I'm wrong, but is the derivative of r sine 2 theta 2 r squared cosine 2 theta?
Say that again?
We're not missing a 2 on the r squared cosine 2 theta from when we took the derivative.
There was a
of
one
r,
half. The 2 hits the 1/2 and cancels.
and then you took the derivative again to go from r to r theta on
What?
the cross product.
No, that's
Uh,
constant.
I don't know how to explain it.
I'm not doing any derivatives right now during the cross product.
No.
How you got R theta?
Yeah.
So R theta is in question. Okay. So I got negative R sine theta. R
Oh, sorry.
cos-
You took it from that. Yeah.
Here, the R squared doesn't change it. It's the 2's coming here when we go to cosine.
Okay. Yes.
Okay?
Yep.
We all good?
Yep.
Good. Excellent. Awesome. Let's see. So that is that. And then our K component is what we got, our cosine squared theta plus R sine squared theta. Oh, that's easy. That simplifies to R. So that's our IJK components, and we need the magnitude of that. So I think we're gonna need a new clipboard or a new whiteboard here. Let's start getting that set up, see what it looks like. So when we square the I component, we got R to the 4th. I'm gonna just say this. I'm saying this is inside the radical. I want to clean it up without having all the radical and integral all over the place while I do it. So we're just finding the norm. So I've got R to the 4th sine squared theta cosine squared 2 theta plus R to the 4th cosine squared theta cosine squared 2 theta plus sine squared theta sine squared 2 theta. And then plus R squared from K. Yeah, I'll put this over here at the end. All right, hopefully this cleans up. I see some cosine squared 2 thetas. Let's try to group that shit together, see what we get. So I've got, if I do the cosine squared
Yeah.
thetas together, what?
Oh, was that?
Was lost.
Jones?
Yeah, did I make a mistake?
If you look at that cross product again, how did you do the,
In the I.
for the
The
I
I
component?
Oh, yeah.
Did you forget to
I
subtract?
think you missed a
I
part of
didn't
it.
finish it, did I? I totally didn't finish it.
I'm just looking at that, like, yeah.
That's fucking great. Minus, we got an R squared.
Just redeemed myself.
That better?
And then I woke up.
I'm totally fucking up all sorts of shit on what I did. Because I didn't even square this correctly.
So, it's in there's-
All right, so let's look at each component squared before we add them together. Thank you. I knew something looked funny. So if I square I've got to do A minus B. That's like effectively A minus B squared. So A squared minus 2AB plus B squared. So A squared is what I had. R to the 4th sine squared theta. This problem got really fucking ugly, didn't it? And then I've got minus 2 times AB. This is A, and this is B. So R to the 4th, sine theta, cosine theta, cosine 2 theta, sine 2 theta. And then I got plus B squared, which is this one. So plus R to the 4th, cosine squared theta, sine squared 2 theta. Jesus, that's fucking ugly. Let's see if we get something nice with J that cancels it out. So I'm going to rewrite J here so that we have it. The negative doesn't matter because we're going to square it out. We've got R squared, cosine theta, cosine 2 theta. Let me change colors so that I and J look different. J is R squared. I haven't squared it yet. I'm just popping the line down.
I think the kids are
So when we square this, this one's going to be A squared plus 2AB. So I've got R squared. I'm sorry, R to the 4th. Cosine squared theta. Cosine squared 2 theta. Plus 2R to the 4th. Cosine theta, sine theta, cosine 2 theta, sine 2 theta. That's good. That's going to cancel out the I component. And then R plus R to the 4th, sine squared theta, sine squared 2 theta.
like this.
So this is J squared. And K squared was R squared. So we're adding this shit together. What cancels out? Well, this is going to cancel out this, right?
I agree.
So I've got R to the 4th. There's a lot of R to the 4th. I'm going to write that outside. I've got sine squared 2 theta. I'll go back to black, thinner pen.
No, I just shifted all the.
Oh, that can go out. You can combine all the other parts.
I can get me on the next one. My final grade.
And I'm going to put the other cosine 2 theta here real quick. So that's that one and that one.
Next one. I did a on the next one.
Plus an R squared. We still have the plus the R squared. But that addressed that term and that term. So we got more stuff that cancels. I can see it. If I group the cosine squared 2 thetas together, I've got sine squared theta plus cosine squared theta, which is just 1. So this just gets me cosine squared 2 theta with that group. And this group, if I group together the sine squared thetas, or 2 thetas, I'm left with, oops, cosine squared and sine squared again. That goes to 1, so that's that. And then I've got plus R squared. This is where we're at so far.
So we're getting R4
So
That's
it's just r to the fourth plus r squared. And if we have that in a radical, this is just r times r squared plus 1. Well, it's technically the absolute value of r, but r is going to be a radius, so it's going to be positive. So we don't really need it. So that's our norm. That's the dr du cross dr dv norm.
It's just write down. Gives me the answer.
So we s equals our integral. I'm going back. We had r was from 0 to 3 and theta was 0 to pi over 6. I've got r times r squared plus 1. My dA is in r and theta, r dr d theta. So this makes this an r squared. I'll put the r over here and get rid of that r there. And so maybe a u sub here.
This was on the test. I wouldn't expect anybody to finish the test.
Well, I mean, max time's gonna
But
be
this-
like
if we- if
1
you can
4
do this, then
hours.
you should be fine.
I do 13 is 2.5 hours.
I don't know. You just ask Mr. Jones when he wants if he wants to come at 4 a.m.
2 days. That's like 8.
I don't know what you guys are crying. It's only been 20 minutes.
Yeah, we're just like,
Yeah,
don't know what we're gonna
What do you mean?
expecting on the path.
So we have an r go away here, right? I don't know that this helped, did it?
Wait, question.
if he's asking expecting for an hour test, this is that's like a third of the test right here.
I hope that's gonna be like, if that's 1 hour test, I guess there's only 2 questions on test.
Just doesn't help. Because I still have an r, and r is the square root of u squared minus 1.
This will probably not be on the test. Instead, you'll probably have a center of mass problem that'll take half your time instead.
Huh. That doesn't help. Was I supposed to use RD theta? Did I jump the gun, or does that come into play using the DRDU? Let's come back and look at it. I got an example in polar coordinates. Beautiful.
Find something you can put that word.
What?
Yeah, RDR.
This is really cool. Check this out. And then let's do it corrections.
All right, so any ideas? Wait. Yeah, it was an R. We pull out an R.
That helps if we use U square equal R square plus one. No, it doesn't.
Ooh, I like where you're going there. Let's give that a try. U squared equals R squared plus 1.
That may complicate it. Not really.
It's 2du, 2r. You still have an r on the outside, I feel like.
Then we're getting another.
And then you have like
shift.
a whole fund right there. And then you can solve for u. Ooh. Yes, question?
Why do we even have an R squared in front of the radical anyways? We found that we have the absolute value of R times the square root of R squared plus 1.
Because one of the R's was from that and the other R was from R d theta.
Yes, right.
Oh,
I'll re-put it like that so that we have it, so you can see it.
I feel like the sound of a student just losing their energy like very slowly, or at least losing their soul.
We still ended up having a, we don't have an,
No, you're just shifting the content, that's it. Huh?
is this gonna be an integration by parts?
And look, you can do that.
Oh,
You can definitely do that.
This might be an integration by parts. Let's come back and look at the rest of this problem later. All right. I don't want to waste the rest of the hour doing that. So let's look at something else. Let's find the parametric equations for the proportion of the cylinder. We've got two parts. X squared plus y squared equals 5. Between z equals 0 and z equals 1. And then we're going to do x squared plus z squared equals 4. That's between the planes y equals 1 and y equals 3. And we're doing the surface area. So it's a cylinder. We're not looking for the volume inside, so we don't need the radius from 0 to a number. It looks like for A, R squared equals 5, so R is the square root of 5. So I don't need, like, if I do R and theta, I don't really need R. So let's, rather than using theta, because theta makes me want to use R, I'm going to use, let's use U for the angle. So X equals R cosine U. And Y equals R sine U. And if we want to have a V, maybe we can just make Z equal V. That gives us a vertical component. But I don't need R anymore because we know what R is. It's fixed. It's square root of 5. And Z equals V. So our vector would be root 5 cosine U. root 5 sine u, and b.
This side of you.
So what about b?
Doing one at a time.
X squared plus z squared is in this. It's in the xz plane. It's a circle in the xz plane. And we're going from y equals 1 to y equals 3. So we have like this tube here.
I see, sure.
So maybe we can make the y equal v. We still got a circle. Let's draw that xz plane and see how we could parameterize it. So we got a circle.
Looks like the back.
This was x squared plus z squared equals 4. Let me bring that back up. You can see it.
Oh, you was right.
So the r is 2 here, right? Radius of 2. So we could say for any given point, x is still r cosine theta, 2 cosine, let's go with u. And now z is like our y. So z will get the sine. So x is 2 cosine u. Z equals 2 sine u. So our r.
Yeah.
Yes.
Does that make sense? So we're so used to y being r sine theta, but the way we've done the picture, it's z this time.
This one, the white is R. Radius with 2. Like in our philosophy, the white is like yeah, that's 1 pi, right? That's kind of weird. Just ignore it. Yeah. Just ignore it.
Oh, it's a permanent, yeah. 2 pi r, so yeah, 4 pi.
1 pi. Make the world the way you want it to be. Wise. Here, between. Change your coordinate system.
Get a negative that is that's true.
Are you you're looking for surface area, right? But it's a whole lot of system that we got access to. Not surface area. It's like the same groups.
You know, you should just ask me on one day.
I've taken too much calculus. I don't know how to find the surface area without.
It's easy question like that.
That means
I can double check with 0.
Yeah, you should be able to.
yeah,
Yeah, that's right.
Any questions?
You want to ask questions?
Yeah. So, Mr. Jones, so I can literally using geometry to like double check the answer like easier than calculus with this kind of question.
I don't understand.
Circle, the circle x squared plus z squared equal 4. R is 2, so the perimeter is 4 pi. Then times between y plane, y equal 1.
Perimeter is not 4 pi. Perimeter is 2 pi r, which would be 8 pi. No, you're right. You're right. 4 pi. Okay. Sorry. Go ahead. What? What's the
Yeah,
perimeter?
if I using the perimeter times the length in y direction, which is 2, that gave me 8 pi. Is that gonna be the answer? You have that
It
answer or
should
not?
be 8 pi, right?
Yeah,
If we, but here, we weren't doing the integrals, we were just doing the parameters, practicing doing parameters. You know what's funny? That long drawn ass problem, I want to show you where I got it. Number 4. Wait, nope, not number 4. Where is it? Number 7.
Lucky son.
This is the problem we were working on that was taking so fucking long. Number 7.
I love the solution manual then.
Yeah, but I don't have the solutions manual and it's cheating. Should be able to find a way out of the solutions manual.
I'm not in the next 4 minutes. Well,
Other than that, it's there's 4 minutes left, so I don't really have anything more other than we can keep working on that problem. Maybe try integration by parts.
oh shit. I guess we're doing something wrong. So the manual doesn't have it. Square over there. They're, which have the second.
If I were to do integration by parts, what would I want to do?
go back to that.
I shouldn't do that, I don't
Oh, well.
Oh, we almost had it. But you have to
Yeah,
mark
it's like
where.
where it's just learning algebra for the first time.
I think it's like this.
I don't know if this is getting any better.
Not supposed to have it squared there. There's so much geometry that I forgot.
Oh.
Everything I forgot.
Why am I not supposed to? Oh. Yeah. You equal- There we go. Let's do that.
Trust me, you can't see it.
You don't have
Oh,
to show enough.
shit. Sorry. Let's do that.
Yo.
What?
You'll need them.
So
You see one of the R's is constant.
Don't forget my business.
So let's look at it.
if I do a U, I could do W equals R squared plus 1. DW, 1/2 DW equals R DR.
You have this. Lots of- How many you see that, you're gonna be like.
I got these backwards. Let's switch these.
Well,
Let's make that DV
Brendan, you might be telling him this.
and U equals V. So I can do that. So DV equals,
Oh, the. Oh, they.
so now we can do that. So W equals
This is a solution book. I don't know if it's the answer or not.
1/2 DW equals RDR.
It's like Vermont.
And this switches to DV equals,
Hey, Mr. Jones, what question did you say this was?
number 7.
Oh, I see, yeah.
1/2 the square root of W DW.
Yeah, we first.
I actually.
Would you like to read please? True, true.
I don't know.
I don't know. Did that fucking help?
Yeah.
It's the worst.
That doesn't help, does it?
Yeah. He actually. Oh, oh my God. Look at that. Mr. Jones, we've been doing it the hard way the entire time.
Was he sick when he took?
So what's the easy way?
That's why he took the test?
You know the z equals x, y? They took the two partials, they took that on the partials of both.
I can't hear you because there's people closer to the mic than you talking.
Okay.
So what's the easy way?
So they took the z equals x, y. They took the two partials of dx dy and dx dz or dx or sorry dz dy and dz dx. They took the two partials there, which gave you just x and y. Put that into the definition of a surface area, which is the square root of the partials.
That's
Partial
some
one square.
bullshit. Because it says convert the integral to fucking polar coordinates.
And then it will. Yeah, it actually converts it to polar coordinates after that. Because it adds x squared plus y squared plus 1, and then does r squared plus 1, and it has the r on the outside, then does a u sum. Yeah, that's pretty broken. That's rude.
Maybe,
That's some bullshit.
maybe we did something wrong when we take the
We also did it a different way as well, because
differentiate
we used to
partial derivative. Maybe we're doing something wrong in there.
no.
We should
Well,
try to double
no,
check.
he did fine. The reason it went haywire was because of the way it stopped, because he did the polar coordinates before taking the differentiation.
Does anyone have
That-
the solution manual on PDF that can mail it to me? You guys have-
On PDF or
Oh,
something.
yeah.
I think Eric's about to take. Were you about to take a picture?
No, you want a whole book? I'll just,
Yeah, if you got the PDF, send me the whole book. Yeah.
okay.
That's some bullshit because that is not what it said.
Oh, really?
It's look, it's still on the screen.
Oh, convert and then do it. Oh, that's what you're saying.
So finding the surface area, that's you do the surface area after you've converted it. So it says express the area of the given surface as an iterated double integral in polar coordinates.
Oh my gosh. I think they just done. I think they done goofed us all.
I don't know that what they did that I like that.
Oh man.
Huh. I guess I can stop recording.